Hi everyone, a very warm welcome to all of you. This is the video of thermodynamics for BARC exam. So one student asked me to make video on thermodynamics in community tab. So that's why I am making this video. Okay, so I have already made videos on this thermodynamics at the initial stage of my channel. I started my channel in November. So if you see these intensive properties, extensive properties, system and everything, 5 to 6 videos I have already made. Okay, if you haven't watched it, please go and watch that video. Why I'm saying, I agree those videos are not with quality because at the initial stage of my channel I made those videos. So if you can manage yourself, just see those videos if you want to have more clarity on this, because this is very short, because here I'm giving short notes for your BARC exam. If you want to have more clarity, okay, you have to watch those videos. So because I have explained in a very clear manner, really here really I'm proud of myself. In a very clear way I have explained those videos. If you want to get a very good clarity on intensive properties, extensive properties and everything, you can watch those videos, check the playlist. Okay, so that's all. So we start the class. Okay, so first of all, the first one is system. System is of 3 types, you know this: open system, closed system, isolated system. So actually we have to do the questions. Okay, you know what is this open system, what is the closed system, what is the isolated system. We don't need to study about those things again. Okay, so we have to do the questions. So first of all, what is the open system? Energy, mass, both will exchange between the system and surrounding. That is the open system, you know this. Next, closed system, only energy will exchange, not matter. Okay, isolated system, neither energy nor mass will exchange. Okay, so if you ask the questions, for suppose I ask you one question here. So warming, so the first one, warming ammonium chloride with NaOH. Okay, ammonium chloride I'm taking in one test tube. I don't have any space here, that's why I'm not writing. Just try to understand, because you are the BARC students, you can easily understand. Okay, so I'm just one test tube is there. So in test tube I'm just taking ammonium chloride solution. Okay, so this ammonium chloride solution I'm just warming or heating with sodium hydroxide. Okay, what happens whenever this ammonium chloride solution reacting with sodium hydroxide, what will happen? Ammonia gas will release plus sodium chloride plus water. Okay, so you can do the reaction ammonium chloride NH4Cl plus NaOH, which is gives rise to ammonia plus NaCl plus water. What happens? Ammonia will release from the test tube. So gas is releasing from the test tube, that means test tube is open system. So this is the example of open system. So they will ask you like this: open system, closed system, isolated system. These are the options. You have to take open system. Okay, so next example, well stopped thermos flask contains some ice cubes. This is thermos flask, contains some ice cubes. Then this system is an example of closed system, open system, isolated system, none. Which system? Isolated system, because thermos flask, whenever you have the thermos walls, neither matter nor energy will exchange between the system and surrounding. So this is isolated system. Last, closed system example, water bottle. Okay, closed water bottle. So neither only energy will exchange. Okay, if you have the water bottle, closed water bottle, this is the closed system. Energy will exchange but not matter. So this is the example of closed system. Okay, so this is about the system: open system, closed system, isolated system. They might ask the examples. Okay, next, intensive properties. This intensive properties, extensive properties, you can watch those videos. I have already told you. So first of all, density. Okay, density. Density is the intensive property. Here, molarity. So you take any type of concentration. All types of concentrations are intensive properties. Extensive by extensive equal to intensive. For suppose if you take the molarity formula, number of moles by volume. Okay, number of moles of solute by volume of the solution in liters. So number of moles is an extensive property. Okay, volume is an extensive property. Extensive by extensive equal to intensive. So see, what is intensive property? Independent on the size or independent of the mass of the substance, right? For suppose you take any container, you take one container, 5 centimeters length is there initially. So if you cut this container like this, if you bisect this container like this, you will have two parts. Now if these two parts also, if this one first piece is 5 centimeters, the second piece is also 5 centimeters, then there is no change in the size. That means it does not depends on the size, so it is independent, so it is intensive property. So if it is 3 centimeters, second one is 2 centimeters, then there is a size difference. There is a size difference. Initial is 5 centimeters, but it is 3 and 2. So that's why this is extensive property. Okay, you can watch those videos to get more clarity on these things. So intensive property, all types of concentrations, extensive by extensive equal to intensive. You take extensive property. If you divide these two, you will get intensive. Okay, all types of concentrations are intensive properties. So all types of concentrations means molality, normality, mole fraction. These are all intensive properties. Standard cell potential is intensive property, and pH of the solution is intensive property. Mass percentage intensive property. Molecular weight and atomic weights are intensive property. These are main important things of intensive properties. Extensive properties, all kinds of energies. You take kinetic energy, potential energy, internal energy, entropy, enthalpy, Gibbs free energy. You take any type of energy, those all energies are comes under extensive properties. Length, just I explained about the length, right? So length is an extensive property, right? It depends on the size of the substance. So that's the reason why length is extensive property. If you take the mass is extensive property. Mole is extensive property. Volume, extensive property. Why volume is extensive property? If you take water bottle, 10 liters water bottle, if you take 5 liters water bottle, so it depends on size. Volume, initially if I take this size of water bottle, this is 10 liters, volume is 10 liters. If you take this size of water bottle, then this is 5 liters, right? So it depends upon the size. So that's why this is volume is extensive property, right? Intensive means independent. Okay, extensive properties means dependent. So volume is dependent. So extensive property. Area, so area is extensive property. Okay, these are important properties of extensive. Next one, all types of concentrations. I have already said this. All types of concentrations are intensive properties. All type of constants. You take equilibrium constant, Boltzmann constant, Avogadro number, gas constant. So you take any type of constant. Okay, so those are intensive properties. All types of concentrations are intensive. All types of constants are also intensive. Next, isothermal process. Iso means constant, thermal means temperature. So delta T equal to 0. Isobaric, again isobaric, baric means pressure, iso means constant, delta P equal to 0. Isochoric, choric means volume, delta V equal to 0. Adiabatic means Q equal to 0. So next one, reversible process. I have already explained these all things in my lectures. Okay, so reversible process. For reversible process, external pressure is approximately equal to the gaseous pressure. Gaseous pressure means internal pressure of the system. If you take the internal pressure of the system, if you take this beaker, in beaker we have the gas. So this is the pressure of the gas. Okay, so external pressure, which is almost equal to internal pressure or gaseous pressure, that is reversible process. In irreversible process, external pressure might greater than gaseous pressure, or external pressure P external is less than P gas. Okay, these are important things. Next one, here if you see path functions and state functions, accept work, heat and heat capacity. Accept work, heat and heat capacity. You have to remember these three things. Work, heat and heat capacity are path functions. Accept work, heat and heat capacity. Remaining everything is state function. For suppose I am taking this triangle here. Okay, this is A, this is B, this is C. A to C, if I take delta U1, okay, A to B, B to C, delta U2. Okay, so change in internal energy is the state function. It does not depends on path. So even if you go through A to C or A to B to C, delta U1 equal to delta U2, because they are state functions, it does not depends on path. So the answer is delta U1 equal to delta U2. But if I take in place of delta U1, if I take W1, in place of delta U2, if I take W2, then W1 not equal to W2. Why? W work is a path function. Work, heat and heat capacity are path functions. So it depends on path, not on state. So if you take this path A to C, W1 will have one value. If you take this path A to B, B to C, W2 will have another value, right? So that's the reason why W1 not equal to W2. So if you take this delta U internal energy, delta U1 equal to delta U2. This type of questions might ask. Next one, this is W equal to minus P external dV. This is very important formula, work done formula, and this is very important. Many times in GATE, so many students done mistake here. Okay, so remember, work done by the system, negative. Always you have to represent your work. If examiner will ask you by the system, okay, you have to read question carefully. If work done by the system, you have to give your answer in negative. So work done by the system is negative, work done on the system is positive, and W equal to minus P external dV. dV means change in volume, so volume of the final minus volume of the initial. Next, work done against vacuum or work done during free expansion, W equal to 0. Work done against vacuum or work done during free expansion, W equal to 0. Why? Since external pressure is 0. Since external pressure is 0. Okay, I have already explained this also. Okay, in a very clear manner I have explained this. Okay, so why external pressure is 0? गैस तेजी से ऊपर भागता चला जा रहा है, लेकिन बाहर से उस पर कोई भी प्रेशर नहीं लग रहा है उसके रोकने के लिए. Okay, so that's the reason why actually external pressure is 0. That's the reason why here work done is 0. So here next one, work and heat both are boundary properties. Okay, work appears at the boundary of the system. This is also very important. Work and heat are boundary properties, neither intensive nor extensive. So this can be asked in the exam. Okay, work and heat both are boundary properties, not intensive, not extensive. Okay, next these units you have to remember. 1 liter bar equal to 100 joules, 1 liter atma equal to 101.3 joules, 1 calorie equal to 4.184 joules. 1 calorie equal to 4.184 joules. So next one, internal energy U equal to function of temperature. Change internal energy is a function of temperature for ideal gas. Okay, for ideal gas, internal energy is a function of temperature. That means at constant temperature. Whenever examiner mentioned constant temperature, that means delta U, change in internal energy, is 0. And one thing remember, in thermodynamics you always have to mention internal energy in change only. You have to write delta U equal to 0, not U equal to 0. Okay, so whenever temperature is constant, delta U equal to 0. Last one, du by dv, change in internal energy with respect to anything. Change in internal energy with respect to the volume, change in internal energy with respect to the pressure, du by dv at constant temperature. At constant temperature, if you take change in internal energy with respect to any variable, either volume, pressure, anything you take, change in internal energy at constant temperature is always 0. Okay, this is also very important. So du by dv at constant T equal to 0, du by dp at constant T equal to 0. Okay, change in heat, change in work, change in internal energy, where W equal to minus P delta V. Okay, so next, delta H equal to QP, heat, at constant pressure. Change in enthalpy, change in internal energy. This is also very important point. Delta U equal to QV. These formulas are very important. Delta H equal to QP, delta U equal to QV, delta NG, number of moles of gas, change in number of moles of gas, delta NG equal to number of moles of product of gas minus number of moles of reactant of gas. Okay, so they will give you one reaction, examiner will give you one reaction, you have to apply this formula, delta NG. So this is very important formula, very important formula. In fact, delta H equal to delta U plus delta NG RT. You have to find out delta NG by using this equation, and you have to put the value here. You have to put gas constant 8.314 joule per Kelvin per mole. You know this. Temperature, examiner will give to you. Okay, will be given to you. So you have to put those values here, and you have to find out delta H or delta U according to the question. Next, heat capacity C equal to Q by dt or delta T. We can say change in temperature, we have heat. This is heat capacity representation, C equal to Q by delta T or dt. CS, specific heat capacity. So specific heat capacity formula, CS equal to Q by M into dt. You don't need to remember the definitions for questions. Okay, you have to do the questions only. So that's why you remember these formulas only. Q by M into dt. Okay, here M is mass, specific amount. Okay, specific amount. And Cm, molar heat capacity, Q by N into dt. N means number of moles, you have to present here. Next, Cv, heat capacity at constant volume, Cv equal to Qv by N into dt. Heat capacity at constant volume, right? Heat capacity at constant volume, Qv by N into dt, number of moles, here heat at constant volume. Cp, heat capacity at constant pressure equal to heat at constant pressure by number of moles into dt, change in temperature, Tf minus Ti you have to take. Next important formula, very important formula, Cp minus Cv equal to R if you have the 1 mole of gas. If you have n moles of gas, Ncp minus Ncv equal to Nr. If you have only 1 mole of gas, Cp minus Cv equal to R. This formula important. Next, Cp is greater than Cv always. Why? Cp equal to Q plus W. Okay, so you are adding W to the Q. That means you are adding something. That means Cp value is high, Cv equal to Q only. So Cp value is low. So Cp is always greater than Cv. This is for gaseous. Okay, for gaseous, for gas molecules, Cp minus Cv equal to R. For liquid or solid, okay, if you have the liquid or if you have the solid, then Cp is approximately Cv. Cp is approximately equal to Cv. And for solid also, Cp is approximately equal to Cv. Next very important formula, Cp by Cv equal to gamma. Okay, I think this is the Poisson's equation, right? Yes, Cp by Cv equal to gamma. So this is very important. Next, Cv equal to, so you have to remember these all formulas. You have to note down. Okay, you have to note down in one page only or in 2 pages only. You have to revise again you have to revise. Okay, Cv equal to F by 2 R. F is nothing but your degrees of freedom. Okay, F is nothing but your degrees of freedom. Cv equal to F by 2 into R gas constant. Cp equal to F plus 2 by 2 R. F plus 2 over 2 into R. Okay, Cp. Cp by Cv. Just do this. Cp, you take this formula over Cv. You take this one, you will get this. F plus 2 by F. Cp by Cv equal to F plus 2 by F equal to gamma. Equal to gamma. Because Cp by Cv equal to gamma here. Cp by Cv equal to F plus 2 by F here because of these two formulas. So Cp by Cv equal to, overall we can write like this, gamma equal to F plus 2 by F, right? Okay. So for suppose if I take the monoatomic gas means helium, neon, argon, like that. So you take monoatomic gas, degrees of freedom for monoatomic gas. If you can remember this chart. If you don't want to remember, just remember the formulas according to the question. You have to put your values in these formulas so that you will get this chart. Okay, you don't need to remember this whole chart. If you can remember, otherwise just remember the formula. Monoatomic gas, degrees of freedom 3. Cv, if you put this degrees of freedom in this Cv formula, you will get 3R by 2. If you put this value in Cp formula, you will get 5R by 2. And if you do Cp by Cv, then you will get gamma 5 by 3. Right, monoatomic gas 3R by 2, 5R by 2, 5 by 3. If you have diatomic gas like dihydrogen, dinitrogen, dioxygen, like that, dichlorine, like that. So diatomic gas, degrees of freedom 5, Cb 5R by 2, Cp 7R by 2, gamma 7 by 5. Triatomic molecules. If you have triatomic molecules like triatomic molecules, H2O, triatomic molecule. So if your triatomic molecule is linear, then degrees of freedom is 7. If it is non-linear, degrees of freedom is 6. Okay. For Cv, linear, if you have the linear molecule, then Cv equal to 7R by 2, Cp 9R by 2, gamma 9 by 7. If non-linear triatomic molecule, then Cv 3R, Cp 4R, gamma equal to 4 by 3. Remember. Next important formula, reversible, work done in reversible isothermal process. Work done in reversible isothermal process, minus 2.303 nRT log Vf by Vi, volume of final by volume of initial. Right, if you take pressure, just reverse Pi by Pf. Here Vf by Vi, if you take pressure, just reverse Pi by Pf. Next, work done in irreversible isothermal process, W irreversible equal to minus P external dV, that means minus P external into V2 minus V1, volume of final minus volume of initial. Next important formula, Pv power gamma equal to constant, that means P1 V1 power gamma equal to P2 V2 power gamma. You have to use these formulas in your questions of thermodynamics. So Pv power gamma equal to constant, Pv power gamma minus 1 equal to constant, P power gamma into P power 1 minus gamma equal to constant. These two formulas are useful when examiner will ask you about the reversible adiabatic process. By using reversible adiabatic process, if you want to calculate final temperature, in reversible adiabatic process, you have to use these two formulas, Tv power gamma minus 1 equal to constant, T power gamma into P power minus 1 minus gamma equal to constant. And if irreversible adiabatic process, okay, if you want to calculate final temperature, you have to use the formula NCV into Tf minus Ti. NCV into Tf minus Ti. Okay, NCV into final temperature minus initial temperature. By using this formula, you can calculate final temperature in irreversible adiabatic process. Okay, by using these two formulas, you can calculate final temperature in reversible adiabatic process. Okay, work done in isothermal process is greater than work done in adiabatic process if the process is expansion. Next, du equal to ncv dt, very important formula, you have to remember. Directly questions will come on this too. Du equal to ncv dt, dh equal to ncp dt. Right, dt means temperature you have to take T2 minus T1, T final minus T initial, you have to take Cv and Cp values, number of moles, N means. Next, change in entropy delta S equal to positive for gaseous molecules, liquid and solid state. Okay, so in all three cases delta S equal to positive when entropy of mixing is entropy of mixing delta S equal to positive for gaseous, liquid and solids, right? And this, if you take the entropy is directly proportional to the molecular weight. For suppose if I take water molecule and if I take O2, right, you have to calculate the molecular weight. Which molecular weight is higher, right? That is directly proportional to the entropy. If molecular weight increase, entropy increase. Next, if you take the ore of metal and pure metal and ore of metal, the entropy of ore of metal, okay, metal ore is very very high than pure metal. This is also important, might ask. Next, change in entropy ds equal to q reversible by t for the reversible process. Only for the reversible process, this change in entropy is equal to q reversible by t. This formula you have to remember. This formula is very very important. And also ds equal to 0 when cyclic reversible process. For normal reversible process, this is the formula. If mentions cyclic reversible process, why? If it is a cyclic process, this ds is state function. For cyclic process, so this state function is 0. So ds equal to 0 when it is cyclic reversible process. Okay. Next, reversible adiabatic process. For reversible adiabatic process, ds change in entropy equal to 0. And reversible isothermal process. For reversible isothermal process, formula is 2.303 nr log Vf by Vi, V final by V initial. Okay. Next, if the process is from V1 T1 to V2 T2, okay, volume temperature variables are there only. If the system involves volume and temperature only, so V1 T1 to V2 T2. If the system goes from V1 T1 to V2 T2, then the formula is ds change in entropy equal to n number of moles into n Cv ln T2 by T1 plus nr ln V2 by V1. Okay, so if the process is from P1 T1 to P2 T2, means temperature and pressure variables are there, then NCP ln T2 by T1 plus nr ln P1 by P2. Here V2 by V1, here it is just reverse. When pressure is there, so P1 by P2. NCP ln T2 by T1 plus nr ln P1 by P2. This is the formula. If only isobaric process, what happens? Isobaric process, so pressure is constant. Okay, so P1 by P2 is not there, change in pressure is not there. So this term you can neglect. You have to use this formula only. For isobaric process, NCP ln T2 by T1. For isochoric process, so volume change is 0. So V2 by V1, this term can be neglected. Only you have to use this formula NCV ln T2 by T1. Okay, so these are the formulas. So these two formulas are also very very important. Next, change in entropy of a reaction equal to change in entropy of product minus change in entropy of reactant. Right, product minus reactant you have to take. This formula also very very important. Right, next one, if cyclic reversible process, change in entropy of universe equal to 0. If it is non-cyclic reversible process, change in entropy of universe is greater than 0. This is nothing but your second law of thermodynamics, right? Change in entropy of universe is greater than 0. Second law of thermodynamics. If it is cyclic irreversible process, then change in entropy of universe is greater than 0. Okay, in these two conditions, non-cyclic reversible and cyclic irreversible, ds universe is greater than 0. Here cyclic reversible process, ds universe is equal to 0. And this formula is very very important formula, delta G equal to delta H minus T delta S. On this formula direct questions will come. Next, the relation between delta G and delta G naught Gibbs free energy and standard Gibbs free energy, delta G equal to delta G naught plus RT ln QC. Here QC is nothing but quotient, right? So here the QC is nothing but quotient, QC equal to concentration of product by concentration of reactant, right? Concentration of product by concentration of reactant. And again, Carnot cycle is very very important. If I have the time, I will cover this in the next video. Otherwise, you have to study on your own. Carnot cycle is very very important, and it is better to read by yourself. Alright, so that's all. So this is about the thermodynamics. I have covered almost all the important points and formulas. Okay, if you study these things, I think these are enough. Okay, so if you want to study anything other than this, you can study by yourself. Okay, that's all. Thank you so much. Okay, these are the things.